Guys, we're back. Good morning. Let's take a look at today's lesson 324, perpendicular bisector. Alright, our aim today, how do we write the equation of a perpendicular bisector of a line segment? First, the do now. In the diagram below, triangle ABC has vertices A, 4, 5, B, 2, 1, and C, 7, 3. What is the slope of the altitude drawn from A to BC? So remember, altitudes, right? Altitudes form right angles. Alright, therefore they're perpendicular. Alright, perpendicular lines form right angles. Remember that. So we need our slope of BC. Okay, and now the line drawn to BC is going to be perpendicular to that. So perpendicular lines, right, form right angles. Therefore, from yesterday, remember perpendicular lines, opposite reciprocal slopes. Alright, so first our slope of BC is equal to, you could start counting from B to C. Alright, and that movement would be up 1, 2, right 1, 2, 3, 4, 5. Okay, slope from B to C, up 2, right 5, 2 over 5. Now our slope, that's the opposite reciprocal to that. Alright, let's draw in a line here from A to BC. It would look approximately like so, from A to BC, right, forming right angles. But the big idea here, guys, you just need to take that slope for BC, flip it, which would be 5 over 2, and change the sign. Okay, it was positive, now it's negative. Okay, so if we were to take the slope, you can't very clearly see right now. Okay, it would be some sort of simplified version. All right, if we were to count from A to BC, all right, but just take that fraction, flip it, change the sign. All right, so we would get choice for negative 5 over 2. All right. So today's lesson, perpendicular bisector. You may be thinking, very similar to yesterday, we talked about how to make a perpendicular line. What's required for that? All right, slope, y-intercept, make sure that the slopes are opposite reciprocals of one another. All right. Perpendicular bisector, more specifically, all right, talks about a line. All right, we've talked about, the construction for a perpendicular bisector. We kind of need to think about what's special. What's special about a perpendicular bisector as opposed to just any perpendicular line? All right, so the lines are perpendicular. We're still going to have opposite reciprocal slopes. Okay. However, today they're going to give you a segment, for example, AB. So it could really be anything, like negative 2, 1, and 3, 7. All right, I'm just making up coordinates at this point. Okay, they give you two coordinates of a segment, AB. The perpendicular bisector passes through AB. They're not going to tell you that it has to pass through any specific point. Once we see perpendicular bisector, we also need to know that this line, or this segment, okay, passes through the midpoint of AB. Okay, so remember, when we substitute, right, we get our slope, we have an xy point that it passes through. They're not going to tell you a specific point that it passes through. We have to know, hey, perpendicular bisector, that passes through the midpoint. All right, so take a look at that point there. Once we have the coordinates of the midpoint, we have an xy point that we can substitute. So let's take a look. How do we actually find the midpoint? All right. Now I've aligned some steps above. All right. How do we write the equation of a line? That's the perpendicular bisector. All right, of a given segment, given the segment's two endpoints. So we're going to find the slope of the original line. Nothing's changed there. Right. Find the slope of the original line. Step 1. Step 2. Use opposite reciprocal slopes to find the perpendicular slope, right? Look at that notation from yesterday, M with the little perpendicular symbol. So nothing's changed, all right? We still need an opposite reciprocal slope. All right, step 3 is new here. Find the midpoint, xy, of the line segment, because that's the only point, all right? That's the only point that we definitely know the perpendicular bisector passes through, okay? We'll talk about that formula. And then, same, step 4, use the perpendicular slope and the midpoint, so that midpoint, remember, is our xy now, to substitute into slope-intercept form and solve for the y-intercept b. So, your midpoint formula. They give you two endpoints. All right, if you take a look, 4, 1 is one of the endpoints, and 10, 5 is another one of the endpoints. All right, so the formula is as follows. You can see it, x1 plus x2 divided by 2, and y1 plus y2 divided by 2. It's just an ordered pair, an xy point. Okay, we're essentially taking the average of the x values, so 4 and 10, take the average of that by dividing it by 2, add them together, divide by 2. All right, and then we're taking the average, same thing for the y's. We're taking the average of the y values, and you get the midpoint. All right, so 4, 1, 10, 5. All right, your midpoint for that would be 7, 3. So the perpendicular bisector, we know, would have to pass through the point 7, 3. Let's do one quick example. If this was negative 2, 6, and we had another point that was for negative 8, and we knew that this was the, these were the endpoints of a given segment, we could find the midpoint very easily. So it's good to start with labeling. This would be x1 and y1. This would be x2 and y2. We're going to find the average of the x values, and we're going to find the average of the y values. So your midpoint is, add those x's, negative 2 and 4, and divide it by 2. Add the y's, 6 and negative 8. Divide that by 2. So we have the average of the x's, the average of the y's. All right, so this midpoint here would be equal to negative 2 and 4 gives you 2. Okay, negative 2 plus 4 is 2, divided by 2, that would be 1. Okay, and then it would be 6 plus negative 8, that comes to negative 2, divided by 2 would be negative 1. So that would be your midpoint that you would use. That's your xy point you would use for substitution. All right. So, a complete problem, a regions type question you might see. All right, they give you a line segment. Line segment AB has endpoints negative 1, negative 3, endpoint B, 5, 5. Write the equation of the perpendicular bisector of AB. So all they said was some endpoints. This does not pass through. Those points, all right, are not on the new line. Okay. All they said was we need to produce the equation of the perpendicular bisector. Okay, so you hear perpendicular, right? Opposite reciprocal slopes. Now bisector, that tells you that you need the midpoint. They haven't told you any point that this new line passes through. A is part of the original. B is part of the original. That doesn't help us. Okay, that helps us find the midpoint, but once again, we have to know, we see bisector, we have to get the midpoint. That's what it passes through. All right, so let's start with the midpoint. Labeling is good. x1, y1, x2, y2. All right, just labeling. Here's our first point, here's our second point. Your midpoint formula. A midpoint is just a coordinate. Add the x's, divided by 2. Add the y's, divided by 2. So this would be equal to negative 1 plus 5 divided by 2. The y's, negative 3 plus 5 divided by 2. Negative 1 and 5 is equal to 4. 4 over 2. Negative 3 plus 5 is equal to 2 divided by 2. All right, your midpoint would be 2, 1. Now, guys, this is the xy point we'll end up substituting into slope-intercept form. Because our perpendicular bisector, before we did this, we had no idea of any point that it passed through. Alright? This is one of the points, the many points, this is one of them, that the perpendicular bisector passes through. Now, slope. Alright? For slope. Alright? You do have a slope formula. Some of you like to use that, I noticed in class. Alright, your slope formula is y2 minus y1 over x2 minus x1. The change in the y's over the change in the x's. You can use that if you'd like to. You can also plot the segment and then count the slope. That's easier for some of us. That's the way I'm going to go through here. Alright, but in the meantime, if you want to try the slope formula, you can. So our points were -1, -3, alright, and 5, 5. Just confirm that. Okay. Now, you used to in GeoGebra be able to connect these points. Alright, the only way at this point that would be the easiest probably is to click on vector under lines. You click on vector and then you just touch the 2 points. Alright, it gives you an arrow, but you can see it a little more like it's a segment. Alright, so now you're just going to count the slope. Alright, I'm going to start at A, which would be up 1, 2, 3, 4, 5, 6, 7, 8. Right, 1, 2, 3, 4, 5, 6. Okay, which the more simplified version of that would be to go up 4, right 3, up 4, right 3. Alright, so the slope of the initial segment is 4 over 3. AB has a slope of 4 over 3. Please don't get tricked into using that. That's our slope of the initial segment. We need the slope of the perpendicular line. Okay, so 4 over 3. Our perpendicular slope, remember opposite reciprocals, flip it and change the sign. That would be 3 over 4. It was positive and now it's negative. Okay, so remember when we first started doing this, they'd give you a slope and a point that the line passes through, and you'd have to figure that out. Now we need to get the slope from the 2 points they gave us, go get the slope, and change it to its opposite reciprocal for perpendicular. And in this one, the perpendicular bisector has an additional step of work where we need to find the midpoint. At just any point the perpendicular bisector passes through, that's the only point we know for sure. Alright, so we find the midpoint, we have an xy point. Now, to find the actual equation, we know equations are in slope-intercept form, y equals mx plus b. We're going to use our midpoint and our perpendicular slope. So 1 is equal to the slope of -3 over 4 times x, which is 2, plus b. Alrighty, so 1 is equal to -3/4 times 2. Once again, guys, you can throw that in your calculator if that's a little bit confusing. -3/4 times 2 is -3 over 2. -3 over 2 plus b. Alright, inverse operations, we got to get 3 over 2 to the other side here. And we get that our y-intercept is equal to 1 plus 3 over 2. Which is 5 over 2. You could write that as a fraction. 5 over 2, or a decimal, 2.5. Usually they're left in multiple choice questions as fractions, so I'll leave that as 5 over 2. Okay, so let's bring this all together. Our equation would be y is equal to our perpendicular slope, negative 3 over 4, x, plus 5 over 2, the new y-intercept we just got. Alright, so once again, just to wrap this up in terms of yesterday, guys, our slope, right? We can plot, we can find the slope. Alright, you can use your formula, find the slope. Then we need the opposite reciprocal slope. That's our perpendicular line slope. Flip it, change the sign. What's new today is they didn't give us any point. They didn't tell us any point that our perpendicular bisector passes through. Usually the problem says parallel and passes through the point, whatever, whatever. Or perpendicular and passes through the point, whatever, whatever. They didn't give us any points. They gave us points of the initial line. We know, since they said bisector, hey, we can find a point that this line passes through. All right, that's the midpoint. So we found the midpoint as our xy and substituted that into slope-intercept form. All right, we substituted our perpendicular slope, the midpoint, solved for our new y-intercept like usual, and we have our equation. All right, so you'll try examples 2 and 3. Once again, it says just flat out, here are the endpoints of some segment. What's the equation of the perpendicular bisector? Sort of just a couple steps. Plot it, or use the formula to find slope. All right, we want to find the slope. We want to find the perpendicular slope, negative reciprocals or opposite reciprocals. Flip and change the sign. All right, and also find the midpoint with that new formula. And then ultimately at the end, substitute your slope and substitute your midpoint, find the new y-intercept, and write your equation. All right, guys, please feel free to ask questions and remind. All right, you can now reply to anything that I send you. You can email me. I know a lot of you will find it easier and remind. Please message me. All right, I was responding to some students, all right, at 11 o'clock in the morning yesterday and all the way up until, the nighttime. So please, at any point, message me, ask questions. All right, have a wonderful rest of your day, and I'll see you mañana.